continuing with solving mathematical and scientific formulas. All right, you guys are supposed to do some on your own. We're going to check them right now. We're going to start with problem number 3. All right, problem number 3. Problem number 3, what's the variable we're supposed to solve for? X. All right, so first thing we need to make sure, problem number 3, step number 1, you need to isolate the variable that you're solving for. We're going to isolate this particular variable. All right, so here's our equal sign. Right there. All right. Anybody feel confident to know what they did on their very first step?
I subtracted 4y from this.
There you go. I like it. Subtracted 4y from this side and subtracted 4y from this side. Now, do we know what those are called together? They cancel out to 0. But what do we call them?
Like terms.
Well, they are like terms. You're right. They are like terms. The two terms that add to 0. That's right. Additive inverses is right. Brilliant. All right. So we're gonna. What am I bringing down? I'm bringing down the and x. Good. Equals. Now this is the tricky part, everybody. Are those like terms? So what is 3c minus 4y? That's right. It's just 3c minus 4y. We can't combine them. They're not alike. So we're not going to try to do some crazy voodoo math and try to combine them. All right? Now we're solving for what? Do we have x totally alone? No. What? We have a letter m. Now what is m in relation? What's happening here? M is doing what to x? Is it being added, subtracted, multiplied, divided? It's being multiplied. But you're right. But I think you're thinking of the step we're going to do. But m is being multiplied to x. So what's the reverse operation? Right. We have to divide. We're going to divide everything by.
M.
That's right. Divide this by m and divide this by m. And these m's cancel out to the number.
Oh. 0.
Nope, not 0. M divided by m is 1. So this just becomes a 1, and this isn't x. We don't have to say 1x. All we have to do is just say x. Just like I don't have to say 1 Lauren or 1 Gorgon. I can just say Gorgon or Lauren. So what's our final answer? Our final answer is the same.
X equals 3c minus 4y divided by m.
That's it. That's your final answer for problem number 3. All right, moving on to 4. All right, problem number 4. What are we solving for, everybody? When you scan through this, what are we solving for?
S.
That's right, we're solving for s. All right, here we go. I'm going to highlight the s. All right. So what did you all do first? Solve for s. You got to isolate. You got to get this right here. We got to get this guy totally isolated by itself. We're going to isolate him. Yes, because right now what's hanging out next to Mr. 9s? It's negative 5g. How do we get rid of 5g?
Gonna add 5.
Yeah.
On both sides.
And these are added percent cancels out. We're going to add 5g to this side. So what do we have on the left-hand side of the equal sign? 9. And we have an s equals. Go ahead, see if you got it. Negative 4u plus 5g. There we go. All right, Jake, what do you think the last thing we do here is? Solving for x.
Multiply both sides by 9.
The other thing.
Oh, divide both sides.
There you go, yeah. Divide both sides by 9. Because these, what are we trying to get to? We're trying to get this to just an s. Not a 9s, just an s. So you always do the reverse operation. If If 9 is being multiplied, you can divide. Okay, so here we go. Our final answer, when we divide both sides by 9, is what?
S equals 4u plus 5g divided by 9.
Close. Negative 4u
Oh.
plus 5g, all divided by 9. This is your final result if you solve for x. Okay. All right, number 5. Ooh, solving for b. Solving for b. This should be very easy. You guys should have this process down now. All right. What do we got to get rid of on the left-hand side? What do we got to get rid of? The 3c. How do we get rid of it? There we go. Come on, let's get going there. All right. Uh-oh. What do I have left on the left-hand side of the equal sign? AB. AB. All right. Equals. All right. Anna, what you think? What's this going to be right here? Just tell me what you see. Just tell me what you see. What do you see here? What do you see right there? All right. What's happening there? That's right. That's all you do. Just 2d minus 3c. Why can I not combine those? Because they're not exactly alike. D's can only be added to other D's. C's can only be added to other C's. All right? So if I said, everybody, if I said you have 4 cats, all right, and 3 dogs, all right, what do you have? Yeah, but I'm not right now. But 4, you're right, you have 7 animals. All right, but I didn't, yeah, but right now, you don't have 7 dogs. So like if you said C equals cats, right? If C equals cats, all right, and D equals dogs, then it would be 4C plus 3D. You can't, these are not the same, all right? Yes, they are both animals, but they're not the same, okay? All right? All right, so if I was organizing, you guys go to Walmart, right? You guys see, go to the produce department, you go to a grocery store, okay? You get, there's lots of different kinds of fruit, okay? But they don't have like a pile of apples and oranges in the same pile. They have like oranges, and then you have apples, and then you have bananas. I mean, they don't just mix all the fruit. Yes, there is something called a mixed fruit salad, okay? But I'm saying when you organize stuff, you don't put all of the same stuff together. You have to separate them. That's what we're doing here, okay? So, right now, you're probably going, okay, what do I have to do to finish solving this problem? Stop talking. So right now, what are we solving for? We're solving for b. What's happening to the b? It's being what? Multiplied by a. So what's the last step that we have to do? Right. So how do we get rid of an a that's being multiplied? We do the reverse operation, which is divide both sides by a. Okay? So our final answer is b equals, go ahead, say it.
2d minus 3c divided by 9.
There you go. That's your final answer. All right, number 6. See if they can give us a hard one. So far it's been pretty easy. All right. We're solving for what? We're solving for x. All right? What? And you don't have to do this, but basically what I'm doing right now is I'm just highlighting. So my brain's recognizing this is what I'm trying to get by itself. So right now, if you look over here, what's hanging out next to this k times x? Yeah, you have a negative influence over here, all right? Sometimes you got to stay away from negative influences in life. How do we get rid of them?
Plus q.
Yeah, we have plus q from this side, plus q over here, all right? So now we have what? We have kx on the right-hand side equals, all right, what's that sum? What do you guys think? That's it, just 2p plus q. Can't combine them. Cannot combine p's and q's by adding and subtracting. All right? All right, of course, what do you think the last thing is? We're solving for what? We're solving for x. So what do you think we're going to do?
Divide both sides by k.
That's right, we're going to divide both sides by k. All right? Because k divided by by k is equal to a 1. Just remember that. Any number divided by itself equals a...
K.
No, not a 1. Any number divided by itself is 1. The number 1. Like 5 divided by 5. What's 5 divided by 5? 1. 1 million divided by 1 million? No, just 1. How about 1 billion, people? 1 billion divided by 1 billion? Let's do 1. Very good. Throw me a bone, people. Come on, let's go. So what is our final answer? What is x equal to?
2p plus q divided by 10.
That's it, right there. That's what x is equal to. 2p plus q, all divided by a k. All right, we're getting ready. Folks. All right. So what I'm going to do right now, here we go. Oh my goodness, we're coming up with fractions and letters on both sides. Oh, this is crazy. I want you guys to do number 7 on the board right now. Do 7 on your dry erase board, and we will see if you guys can get this right. Good luck. All right, number 7 was a little bit trickier. All right. Why is number 7 a little bit trickier? Because now we have a fraction here. All right. So you guys did a really good job. The first thing you did to both sides was what? Yeah, get those A's out of the way. So that zeroes out and that zeroes out. So all we had left was what? 2/3 of n equals a c. And we're solving for n. Just remember, we're solving for n. Right? If we're solving for c, everybody, if it said solve for c, guess what? We'd be done. But it doesn't say solve for c. My board's not working. Wake up, board. There we go. Now, what's our word of the day? What's our word of the day, boys and girls? That's right. Multiplicative inverse. That's right. And Gordon, do you know what the multiplicative inverse is of a 2 over 3? That's right, a 3 over 2. You are right, sir. You are right. It's a 3 over 2. Kind of sounds like we're math cousins. What do you call it? All right, so these 3's cancel out. These 2's cancel out. Right? Because 3 divided by 3 is 1. You're right. And 2 divided by 2 is 1. That's right. So what do we have left now? All we have left is 1n equals. Now the product of c times 3 over 2 is just 3 over 2 times c. What do we always lead out? We always lead out with the number in front. Okay? We lead out with this fraction. And that's your final answer for n. What I'd like you to do is put number 8 into your journal. Why do I want you to put number 8 in your journal? Because we're going to be practicing multiplicative inverse. I want you guys to have an example in your journal. So go ahead and put those down right now. All right, everybody, what are we solving for on number 8? That's right, we're solving for h. All right, so I'm going to highlight that. All right. If you made a prediction what I was going to do next, what do you think I would do next? You're right, but the first thing I would do is I'd put those double lines just like that. But you're right. First step I would take away g from this side, and I would take away g from this side, because these are additive inverses, those cancel out. Good job. So now, if you're keeping up, on the left-hand side, we have 2/5 of h equals. Uh-oh. Can I combine those?
No.
Okay, how would you combine it? Go ahead.
Yeah, so d minus g. So I can't combine them as far as being like terms, but I can put a d in front and minus g in the back. So here's what we have, everybody. We have 2/5 times h equals a d minus a g. Now what's the new word of the day, everybody?
Multiplicative inverse.
That's right. So what is the multiplicative inverse of a 2 over 5? Boom. That's what we're talking about. So watch here. So what you got to do is watch. You don't just put the 5 over 2 in front of the d. You got to put a parentheses right here. Okay? You got to put a parentheses around the whole enchilada. All right? The whole thing. So this 2 cancels this 2 out. This 5 cancels this 5 out. And all we have left on the left-hand side is? That's right. Now, let me show you 2 different answers, okay? You might see an answer that looks like this on a multiple choice test, all right? However, you also might see an answer that distributes the 5 over 2 to both letters, So 5 over 2 times d is 5 over 2 d. And 5 over 2 times the negative g is a negative. Stop laughing at the fraction. It's not that funny, okay? I'm just saying. All right? You wouldn't want to be laughed at if you were a fraction that was 5 over 2. You would want to be accepted, okay? All right, so everybody, what I'm telling you right here is this. You might have an answer that looks like these are both correct, all right? These are both correct. Here it's just been distributed, okay? So this is a little bit more simplified because you went through the distributed process. But you might see this as the answer or this as the answer, okay? All right, we're moving all the way down to problem number 12, okay? Hold on, I'll go back. There we go. This could be the answer. If we distribute the 5 halves to both of them, then this would be the answer. Okay. Got it? All right, everybody, this one is really not that difficult of a problem, okay? But I want you to see what happens if you start with something being all divided by a 2, all right? So everybody, if you ever start a problem where you see something in the denominator right here, what is the easiest way to get rid of a 2 in the denominator? Right, right. So if it's being divided by 2 to start out with, the very first step I want you to do is I want you to multiply the numerator by 2. And over here, what are we going to multiply? We're also going to multiply by 2. All right, now the reason we're multiplying both of these by 2 because this 2 will cancel out this 2. And what do I have left now on the left-hand side of the equal sign? Very good. 3b minus 4 equals. And the product of c times 2, how would we write the product of c times 2? We wouldn't say c2. Right. We always put the coefficient up front. So we're going to put 2c. Very good. All right. So now, again, once again, what are we solving for? We're solving for the letter b. All right. So what's our next step? We're trying to isolate this 3b. We're trying to get it by itself, but we have a negative influence over here. We've got a negative 4. What do we got to do to get rid of this negative influence? That's right, you add. That's right, you add 4 to this side, and you have to add 4 to this side. You have to make these additive inverses. Additive inverses always add to
0.
That's right, they always add to 0. Very good. So what do we have on the left-hand side now? 3b. Very good. Very good. Now, this is where it's tricky. Sometimes students try to combine these, but you can't because they're not like terms. So what are we going to put over here on the right-hand side?
2c plus 4.
Boom. 2c plus 4. All right, now, Catherine, here we go. This is all you. All right? Final step, the very final thing. To go from 3 times b to just b, where we get our answer. What's our very final thing we do? Joel, Catherine, she's got it. That's right. We're going to divide both sides by 3. Divide this side by 3 and divide this side by 3. And these 3's will cancel out to a 1. And so our final answer, everybody, is 2c plus 4 all over 3. That's your final answer. Now, the final problem we're going to do today is a problem that you're going to see on a test. It's going to be the kind of problems you're going to see on a test, the unit test. So we're going to go all this practice. What we're going to do, all right? You're going to see a problem like, just so you guys know, a problem like number 15. Okay, where you have to solve for y. Okay, which is an easier one. We're going to do problem number 16. All right, so this will be the final problem that we do today. So go ahead. You don't have to write all of the problem. All I want you to do in your journal is write this. Write a capital S equals 1/2 capital P. It's kind of a funny looking L. It represents the slant height. So make like a funny looking L. Right? Plus capital B. Now I'll make the L a little bit easier to write. Okay, just make the L like this. Alright? So I want you to write the surface area of the pyramid is equal to 1/2 the perimeter of the base times the slant height plus the area of the base. So this is the formula. Okay? Now what we're going to do is we are actually, everybody, we're going to solve for you to write in your journal. Write down this formula and say solve for L. And then I'm going to highlight the L, so we're solving for it, okay? All right, I'm going to write over the test question. This is what a test question will look like, okay? Maybe if you put it in bold letters, like it'll pop out in your journal. Ooh, test question. All right, so here we go. We got to solve for L. So I'm going to put a big old long railroad track right here. We got to isolate this slant height right here. So what do you guys think would be the very first thing you guys would do to get this half of PL by itself? What do you think? Subtract. What are we going to subtract? We're not going to. We're going to subtract capital B, which is the area of the base from both sides. We're going to subtract this, and we got to take away a B over here. Now these aren't like, they're not like terms, okay? So here's what we have. We have a capital S minus a B equals 1/2 P times L. All right. Now from here, actually, there's a couple of ways you could go. Okay, there's a couple of ways to go. So it's not like a one right way to do this. Okay, but what we have to figure out is we got to get this by itself. So what's being multiplied to the L? A half is being multiplied to the L. All right, and a P is being multiplied to the L. Okay. Now, what was the word of the day? Multiplicative inverse. Does anybody know the multiplicative inverse of a half? 2 over 1. So one thing you could do is take both sides, all right? Take both sides right here and multiply it by 2 over 1. So you could do that to start out, okay? Can you guys do that? Just multiply both sides by a 2 over 1. What happens? Oh, I got to put 2 over here.
Why couldn't we do it by 2 though?
It is 2 over 1. Yeah, it's the same. So I just want you to know 2 over 1 is the same as the number 2. Okay? So this, I'll do it in red so you'll see it. So this half cancels out this 2 over 1. Okay? And so what are we left with on the right hand side now? What do we have left? We have a P and a what? P and an L. Equals. Over here, what do we have? We have 2 times S minus a what? S minus B. Alright? So what's our final, last step? If we're solving for L, what's our final step? That's right. Divide. Divide both sides by P. Just P. Because we want to keep the L. If we wanted to get rid of that L, then we divide both sides by P, L will cancel to a 1. We're dividing both sides by P. And the P's will cancel out because any number divided by itself is equal to a 1. So here's our final answer. Our slant height is equal to 2 times the surface area minus the area of the base, all divided by the perimeter of the base. Now I'm going to write the word or, because you could distribute the 2 to both numbers. So you could see the answer 2 capital S, not a 25, 2 capital S minus 2 capital B over capital P. So these are the 2 answers. Now this, everybody, this is a real formula, okay? If you wanted to solve for the slant height and you had all the other pieces, you could, all right? You have the rest of the period to work on those individual problems. Now I will check them, okay? But I want you guys to go ahead and work on the rest.